Next also is ready. Yeah, Java champion, Spring developer advocate, YouTuber, and also blogger, and just a good man. Dan Vega, welcome Dan. How are you?
I am great. Thank you guys so much for having me here. This is going to be a lot of fun today. I'm excited and love the cause that we're all kind of supporting today. So, yeah, please get out there and support the cause if you can.
Cool. So your upcoming talk, Spring, yeah, Spring has been a cornerstone for many Java developers. I'm so
Yep.
excited to start hear you also new adventures in Spring and future.
Yep.
So I
Yep.
hope you will do best because I'm your subscriber. Yeah, at least one subscriber for your more than 50,000 subscribers here.
I
And I
appreciate that.
wish you good luck. And I know you will do it best as usual. So go ahead then.
All right. Thank you so much. Let me go ahead and share my screen. Hopefully, everybody can see that. Um, cool. So, we're going to have some fun today. We're going to be talking about Spring Boot 3 and beyond. Spring Boot 3 was released in November of 2022. I want to kind of cover some of the features that have been released since then and maybe like step back and take a little baseline of what came out in Spring Boot 3. So we can't cover everything in an hour, but I'm going to talk about some of my favorite features in Spring Boot 3, 3.1, 3.2, and even some stuff coming up in 3 that was just released in 3.3. So I want to focus on really around developer experience and runtime efficiency. And we'll do this through a mix of some slides, and then we'll do some live coding. So yes, step back. I'm going to do some live coding today. We'll have some fun with it, though. I can't see your questions, but please get them in. We'll see if we can't jump back and forth and answer questions as we go and answer questions at the end. So a little bit about me. Gracious host there just gave me an awesome introduction. Here's a little bit more about me. If you want to find out, you can go over to danvega.dev. I'm a husband and a father. My beautiful wife, Jen, our 2 daughters, Isabella and Juliana. We live outside of Cleveland, Ohio. As mentioned, I was named a Java champion this year, which was awesome. One of those career goals that I was really excited to have happen this year. I've been doing this a while. I've worn a lot of hats in this industry. Probably my favorite hat is the one I'm wearing now, which is being a Spring developer advocate. And I often tell people that, I was a Spring developer advocate long before anyone was paying me to do so. And so I think one of the lessons I like to kind of teach there is that you don't need permission to advocate for the things that you're passionate about. So whether it's Java or Spring or whatever technology you're really interested in, if you want to write about it, if you want to do a video about it, go out there and advocate for it. You never know where that will kind of lead to. I create content, again, danvega.dev. I'm on the Bird app still. I don't know if we're calling it X or Twitter or what. I'm calling it the Bird app, at the real Dan Vega. And in my spare time, outside of hanging out with the family, I enjoy running and golf. So I want to tell you quickly about a show that we do called Spring Office Hours. This is a free resource. We do a live stream every Monday from 1 to 2 Eastern. And this is your chance to kind of get caught up with everything that's happening in the Spring ecosystem, because there's a lot happening. It's not just Spring Framework. It's not just Spring Boot. There are a whole bunch of projects in the ecosystem. We take a look at the release calendar, find out what's going on. And then we also go ahead and answer your questions. So if you have questions, this is a really good place to bring them. If you can't catch the live stream, you can catch a replay. You can find out more about it on springofficehours.io. We also turn it into a podcast if you want to go ahead and take us in the car or on the run or wherever you are in the go. So check that out, Spring Office Hours. So a quick agenda of what I want to cover today. Again, I said we can't really kind of talk about everything in Spring Boot 3 Plus. That would take forever. So I want to focus on a couple things. I just want to give a quick baseline of what happened in Spring Boot 3 because it will lead into some of the things we're talking about today. And then I want to focus on 2 major themes here today: developer experience and runtime efficiency. From the developer experience standpoint, a new feature in 3.1 was Docker Compose. I want to take a look at that. And then the new client abstractions. So this is the REST client and the JDBC client. From a runtime efficiency standpoint, We'll see which ones we can get into today. There are a few that I'd like to cover. Ahead of time compilation that came in Spring Boot 3 as kind of a precondition for building GraalVM native images. So we'll see if we can kind of talk about that at a high level. Virtual threads is a very big topic in the world of Java and JDK 21. So we'll talk about support for that in Spring Boot 3.2. Project CRaC, kind of another angle of solving the same problem as AOT, but it goes about it a different way, right? Being able to start our apps really fast, consume less memory. Project CRaC takes a shot at that, and so I'll have an example of that. And then CDS, something pretty new to 3.3. Class data sharing. We'll see if we can just talk about that at a high level. So those are my two kind of buckets that I want to talk about today. Let's go. And yes, live coding. We'll do some live coding. So just to kind of level set from Spring Boot 3, there were really 4 major themes with Spring Boot 3. And any one of these could have really been like a highlight of the entire release. But the Spring team did what I think is one of the biggest kind of releases they've ever done because they took on a lot here. And the first one was baselining to Java 17. And at the time, it was a kind of announced, I think 3 or 4 years ago. It was, mixed feelings like, oh, we need to be on Java 17. That is now the baseline. And, a lot of companies were like, hey, we're still on Java 8 in certain applications. We got to make the move to Java 17 now. Now that we've kind of seen like the pattern and Java is released every 6 months, a new release every 6 months, it kind of makes sense. So we even have support for Java 22 at this point, but at the time, now you must be baselined on Java 17. So that was a huge theme in Spring Boot 3. Another one was the move to Jakarta EE. So anywhere that we were using the JavaX namespace, one of the moves was, hey, we have to kind of change that namespace. So if we're using the Servlet API, we have to use that new namespace. This was important because it was, unfortunately, you have to like go through the hoop of making this namespace change just to get the same functionality. But then going forward now we get to see some evolution of the APIs in the Jakarta world that we haven't been able to see. Those APIs have been stagnant for a while. So it's nice to see that those APIs are kind of moving forward. So that was another major theme. Again, we spoke about it, but ahead of time compilation, kind of introducing this new phase as a precondition for, in Spring Boot 3 at least, the ability to create GraalVM native images. And this is all about supporting faster startup times, less memory consumption to support the different workloads that we're taking to production. So we'll kind of touch on that a little bit more later. And observability was a huge theme in Spring Boot 3, kind of rewritten from the ground up, from the framework level, from the observation API that the framework uses that have access to. This was a really big theme, and this was really just the start. If you look at any release, 3.1, 3.2, 3.3, even minor releases, and you look through the release notes, you'll always kind of see something about observability because this story has been continued to be told throughout the 3.x releases. So that was Spring Boot 3, just to kind of recap of where we were with that. I want to talk about developer experience first, because this is very important to me. Like when we're writing code, we want it to be easy. We want it to be joyful writing code. You don't want to have to like sit down and go, I got to go to work today and I got to write this code. I feel like that's how COBOL developers are these days, but they make a lot of money because you can't find COBOL developers these days, right? So developer experience, let's talk about it. I want to talk about Docker Compose. So there is a new Docker Compose module that came in 3.1. We'll talk about like what that is and how it works. And this all kind of centers around the idea of this connection details interface. Then we'll look at the new client abstractions. Again, this is the two that we're going to focus on today are the REST client and the JDBC client. And we'll dive into like where they came from and some examples of how to use them. So Docker Compose. I want to start with this. We have this really cool project. So I have some really cool project. This could be on GitHub somewhere. Maybe it was an open source project. This could be something inside of your organization. You just started a new job and you've been given this document that says, hey, this is application, really cool project. You got to go get started with it. Here's how you get started with it. There's these long documents, right? How to get started, setting up this project, how to like use it. And to even get started with it, you look at this like list of requirements and you go, okay, I got to install Postgres and I need to make sure it's Postgres 16 and I need to make sure port 5432 is open. And we use Kafka, this specific version, this specific port. You can see the requirements here, Redis, Elasticsearch, MongoDB, oh yes, and we have these other microservices that we need to use. Make sure they're running and make sure they're running on these specific ports. All of these things just to be able to clone a repo and get it up and running. I don't know about you, but when I see these requirements, at least on like an open source project, I'm less likely to want to help out or contribute because I don't want to go through the process of trying to set all of this up, right? So this is a common problem. What I want to move to is more of a git, clone, and run experience, right? I just want to be able to clone a repo and run it. I shouldn't have to set anything up. And lucky for us, we have a lot of tools these days that kind of enable this workflow. One of those is Docker Compose. So even outside of the Spring world, if you've ever used Docker or there's really two sides of Docker, right? One is kind of creating these containers. So I have an application. Maybe it's not going to run in an environment where JVM is. I create a container, maybe something like Kubernetes is running there, and I use that container image. The other side of it is being able to consume these containers, right? And so a tool like Docker Compose says, hey, here are the services that I need. When I run Docker Compose up, go ahead and download all these containers for me and let me use them. So we'll see how that's been integrated into Spring. On the developer experiences side as well, we're not going to get into it today, but there's also a new feature for test containers, being able to use those test containers at development time. So that's interesting. And all of this kind of falls around the connection details interface, which we'll walk through. So Docker, you need Docker Desktop installed to take advantage of this feature. That's just a requirement. So I have Docker Desktop running. We'll take a look at an example of this today. But with this running, if I head over to start.spring.io, I pick the latest version of Spring Boot. I fill out some information. I'm saying I'm building a web project with Spring Data JDBC. I pick the PostgreSQL driver, and then I choose the Docker Compose support. Now what the initializer is doing, because we picked the Docker Compose support, it's looking at all of the other dependencies and saying, okay, are any of these services that I could create a Docker Compose file for? In this case, PostgreSQL, yes, you probably want an instance of Postgres, right? So I'm going to create a compose file with that service declared. So this will work with a lot of other services, like if I pick Mongo or Redis or Kafka or whatever the service may be, right? So just by picking the Docker Compose support module and then the correct dependency, what will happen is we get this compose.yaml. So this is, if you ever use Docker Compose, you've probably seen something like this. You declare a service. In this case, it's Postgres. Here's the image. Here's my environment variables. Here's the port. And then you could always run Docker Compose up on this, but you don't need to. But this is just a standard Docker Compose file. Then what happens is if we go ahead and start our application from the IDE, you probably, if you pick through there, I think line number 3 in there says, hey, using Docker Compose file, compose.yaml, and it's doing that by convention. Now we could always change that if you want to like store your compose files in like a Docker folder. And that's just the convention that your organization uses. That's something you can change in the properties, right? But by convention, it's looking for a couple different files. So it sees that. It sees that there's a service declared for Postgres, and it says, okay, I can create that. I can start it, ready to go. Now we have a database up and running. We didn't have to go install one on our local machine, configure it, make sure the ports are open, make sure all that connection stuff happens. We just declared it in a file, ran our application, and there it was for us. So this, for me, is getting me much closer to that git clone run experience. But what does it remember for me? What does it mean for me? It means you don't have to remember to run Docker Compose up before you start your application. That happened to me all the time. I would start my app and go, oh, I didn't have those containers running. So I had to go back and run Docker Compose up and then start my Spring application. It means you don't have to do that anymore. Also, if you have a container running already, say we started Postgres in the morning, and I come back to it later in a different app, I don't need to run that again. Like it's already up and running. We see that we won't touch it, right? The images started by Docker Compose are automatically detected and used to create a connection details bean pointing to the service. And what does this mean? This means that you don't have to put your properties in your configuration, like the data source username, the data source password, the data source URL. You don't have to put those in application.properties and reduplicate those, because there are properties in that compose file, and we can extract those from the compose file and put them into a property source so that at runtime everything kind of lines up. Now, how does that work though? So we have this compose file. We know we have like a DB, a password, a username. We're used to writing properties like this, right? Data source URL, username, password. So how do we get from there to there? Well, it's this thing that I've been referencing called the connection details interface. And what I find really interesting about this is that there are three very, very smart authors on this interface. Moritz, Andy, and Philip, and it is an empty interface, right? No, all jokes aside, this is the connection details interface. If you go in and look at implementations of this, you will see that there's one called the JDBC connection details interface, and there's an implementation of that. So this is how it knows to take what's in that properties or in that compose file and create those properties, the URL, the username, the password, so that those are injected into a property source for you at runtime. So again, it's just a nice little feature, not having to reduplicate properties across the compose to your application properties, right? So that's Docker Compose. Let's talk about JDBC client. A quick history of database abstractions, right? We've had options, and I think one of the things I love about Spring is like we always have like options, different levels of abstractions that we're able to take advantage of. So if you want to, if you're in a Java application and you want to talk to a database, you can. You don't need anything else. You can use JDBC. You can if you have a driver, you can talk to a database. You can use the JDK APIs for talking to a database, and everything will work. But if anybody's, those APIs have been around since the beginning of Java, the beginning of time, which was a long, long time ago, right? Not the easiest thing to work with. So when Spring came along, Spring had this concept of a JDBC template. And it was really just a level of abstraction on top of JDBC, but it made it a lot easier to do the things that we normally do. Like I need to connect to a database, and I need to go ahead and execute some query, get some rows back, and do something with them, right? So JDBC template was that level of abstraction that's been there forever. Then Spring Data came along, right, and added another level of abstraction with things like Spring Data JPA or Spring Data JDBC. Now we can go ahead and just configure some things, create a repository, and now we get all these like CRUD methods out of the box without having to write all of that basic functionality. So those were always there. but what came along was, hey, the web client that we have, or the REST client that we have, it has this nice fluent interface. It's very easy to read. And we know as programmers, most of our job is reading code. We tend to think that we write a lot of code, but we actually read more code than we write. And so having something that's very readable and easy to understand was important. So we ended up with this JDBC client to kind of give you another level of abstraction, just an easier way if you need to write kind of raw SQL and just do all of the interactions that you will with the database. The JDBC client is there to do it. So the reason it was there too is there were some things that we could simplify. One of those was, hey, with the JDBC template, you had to have this notion of a row mapper. So row mapper is a functional interface, so you could kind of do this inline as a Lambda, but you probably are going to need to use this multiple times in the same class. You can extract this out to a variable. But this row mapper is a way to say, like, here's how I'm mapping the columns to a field in my type, in this case, a post. Oops, sorry, wrong one. So you could go through, and again, one of the things with the JDBC template is just kind of all of the different methods that are available. If you look at the API, there's a lot going on there. I might be confused on like which method do I use for this particular instance. Well, we're going to do some live coding with this later, but if you look at the JDBC client, this is very, again, fluent and readable. So the first one is a find all method. You say JDBC client.SQL. Here's the SQL I want to execute. When I call .query on that, you can, instead of, you still have the option to pass in a row mapper. But if you have something that lines up good with your data structure, in this case, I have a record called post, then I can just pass that in there and say, yes, I want you to map this to a post. And then there's this nice list method like, hey, what I'm trying to do with this is just get a bunch of rows out, right? In the second one, I'm passing in the SQL. I'm also using a named parameter here. I'm passing in that parameter as an argument. I'm saying, hey, when we run this query, I want to map this to that post record again. And then there's a method called optional, like, hey, I might get a post back, I might not. What if I pass in an invalid ID, right? So for me, this is just, it's very nice API, it's readable, it's easy to explain to somebody what's going on there. And then there's the REST client. So a quick history of the REST client, and then we'll get into some live coding here. So again, we kind of started, back early on in spring with the idea of a REST template. And this was an abstraction to be able to make it, sitting on top of other tools that actually make the underlying HTTP call. It just gave you a facilitator for making these calls. And it started out with a nice, well-designed API, but over time, as kind of requests came in and issues came in and we need more features, the REST template API kind of ballooned out, right? And from there, when we started working on WebFlux, we put together a web client. It was taking what we learned from the REST template and building out something new. And that web client turned out to be this fluent API. It was asynchronous. It had a whole bunch of nice features. And people really enjoyed using the web client, so much so that in their declarative Spring MVC applications, they would bring in the web client as an external dependency and use the blocking mechanism on the web client because it was nice to use. It was easier to use than the REST template. So what we learned from that was, okay, how can we take what we've learned from the web client and bring that over to Spring MVC? And that's really where the REST client was born. It is a blocking API. It is to be used in imperative applications. And again, just has a nice fluent API, easy to read, easy to understand. And not one of the things that I'll show you in this demo is that, like, when you use the REST template and you kind of create an instance of a REST template, or you get one injected for you, and then you say REST template dot, you're kind of inundated with like all of these methods, right? And all of these overloaded methods. And sometimes you're sitting there scratching your head and I don't know which one of these methods I should use. And it's not like that with the REST client. When I hit REST client dot, I know exactly like what I'm supposed to do. So I really enjoy that. So what is the REST client? Again, it's able to perform HTTP requests and return responses. It has that nice fluent and synchronous API. Builds on everything we learned from the REST template and web client. You can use HTTP interfaces. So we'll see an example of that today, but that uses the REST client in an imperative application. It didn't used to be like this before. I think before 3.2, you had to involve the web client. You had to bring in that dependency if you wanted to use HTTP interfaces. But as of 3.2, that's no longer the case. Now, again, it's important to understand that there are client libraries underneath the hood making this actual HTTP call. And so there are some defaults like the URL connection or the JDK HTTP client, which came in JDK 11. But if your organization is standardized on using some other HTTP client, like the Apache client or the Jetty client, you can swap these out. And there's a way to do that in the API. So that's the REST client. Again, I don't want to get into this because I will actually run through an example of this, and we'll see that today. So I think I just want to jump into a demo. Just checking to see. I have a question here. Is the REST client also just an abstraction, or does it have some internal improvements? So underneath the hood, you can actually pass in a REST template to create an instance of a REST client. I don't know. Again, from an internal improvement standpoint, I don't know. Because again, we're still using clients underneath the hood to make the HTTP call. But there are some improvements from the standpoint of like, yes, this is just a much easier API to use. So just trying to check if there's any questions. All right. So I want to go through a quick demo here. Actually, let me go back to this. And there is a GitHub repo. So github.com/danvega/sb3. If you want to follow this, there's a main branch with a lot of the code I'm going to go through. There's also a starter branch, which I'm going to start with so we can kind of build this out together. But like, there's a little bit of an agenda of some things that we'll go through, right? And then we're going to use a service called JSON placeholder today, which is just a nice way to kind of consume some public APIs without having to worry about authentication or authorization. So we'll end up using this one today. So let me see here. So again, I want to go to start.spring.io. And if I were to come in here and fill this out and say, hey, I want to build out a web project and I want to use Postgres and I want to use the Docker Compose support. If we go ahead and look at Explore, you can see down here that the compose.yaml has a service created for us just because of that other dependency that we had there. If we were to pull in something like Kafka and we go ahead and look at Explore now and we go to compose.yaml, oh, whoops, that's not the one I wanted. Let's do something like, what else does, we'll come back to that. So once I download that, now I can go ahead and look at that compose YAML. So the other thing I want to point out here is the Spring Initializer. I did a quick like YouTube short on this the other day. If you didn't notice, Spring Initializer is now remembering your preferences. So every time I come to start.spring.io, it used to like default to Gradle and Groovy, Java, Java 21, but it remembers your preferences. So last time I was here, I picked Maven and I picked Java 22. So it remembered that. So if I were to go ahead and change this and say, I want to use Gradle Kotlin, and Java 21, and then go ahead and refresh this, you see that it remembers those choices. So just a nice little feature I'm not sure if you were aware of. So in the repo, I give you a little bit of a starter. So if you wanted to like follow this project, you could. But I'm just going to go ahead and start with a little bit of a template here. So when we download this project, we have this compose.yaml. I have updated this just to use a different DB name, a username, and a password. And then I've also mapped the internal port to the container port so that we can connect to this database. So I have Docker for desktop running. And if you look at this, sorry. There it is. I have this Spring Boot 3.1 running just from being able to run this example before. But if we go ahead and start the application, I want to look at this and, oh, sorry. Let's make sure that is not running. That should not be the case. Oh, sorry about that. All right, so when I run this application, again, by convention, we'll see it in here. This is looking for, where is it? Using Docker Compose file, compose.yaml. It says there's already a Docker Compose service running. That's why I wanted to show you the Docker desktop. That's already running, so it doesn't need to start this up for me. And again, if we go to the application.properties, I have some things going on here, but one of which is any connection to a database. I haven't declared any connection to a database in here. And so just with that service file, that compose file there, it's going to run Docker Compose up for us, and we have a service running. We have a connection to a database. So that's up and running. So if we went to our database tools in something like IntelliJ here, I can refresh this, and because I have this schema.sql that creates this table called posts, I have a database that I can connect to right away. And again, this for me is just kind of alleviating some of that like setup of having to set up a database on my local machine, and and a specific version. I can just use what is provided in that service file. So that's kind of step one for me. Now let's talk about building out a little bit of an application here based on the idea of blog posts, right? And we're doing this because that JSON placeholder service has some blog posts that we can consume. So I'm going to come in here in this post class, and I have this post class, and I might want to do something like create some fields for this, right? So in the past, I might say private, let's say private integer ID, private integer user ID, private string title, right? Private string body. So in a class, I might need some other things. I might need a constructor. Maybe we need a no-args constructor because we're going to override that one with an all-args constructor. So I might come in here and generate getters and setters for all of these fields. I might also come in here and say, let's go ahead and create a equals and hash code. So let's do that. All right. And finally, I might need a toString for this. So I come in here and I do that. So all that later for 4 fields, I'm down to 76 lines for just a simple class to represent a type in my system, which is a post. So you probably know where I'm going with this, but we baseline now on Java 17. So we don't need to do this anymore. We can go ahead and turn this into a record. So we can say, hey, I have a record here, and that 76 lines gets turned into a couple lines now, because we can say this thing takes in some arguments. These are record components. I can say I need an integer ID, an integer user ID, string title, and a string body, right? And I'm going to go ahead and put these on separate lines. And now we have just this simple record that is kind of telling us what a post looks like in our system. So I can also come in here and say, hey, I don't want an empty title. And the reason I did that is I just wanted to kind of show you, again, we've baselined on Java JDK 17. We also made the move to Jakarta. So you'll notice the new namespace here. Used to be JavaX.validation. Now it's Jakarta.validation. And again, if you're migrating applications from a previous version of Spring to something like 3.3, this is a change that you'll need to make. Now, there are tools that can help you with this. Even IntelliJ has a nice tool to kind of migrate this. You don't want to just do a find and replace, right? Because some of the JavaX packages come like javax.sql, you wouldn't want to rename those. So there are tools to do this. The IDEs, tools like Open Rewrite, which is really great, allows you to kind of run these recipes and make these migrations automated. So take a look at that if you're interested in making that move. So now that I have a post here, let's see what's next. I want to go ahead and we did some validation. Let's talk about our database abstraction. So now I want to be able to create a post in my system. How do I do it, right? I have this post repository class, and we're going to go through kind of a couple different levels of this. So the first one might be using that JDBC template. And I have some helpers here, so we don't have to watch me type everything out. But I have this JDBC template, and we probably all written code like this, right? So we get a JDBC template auto-wired for us. We can call different methods like update or query. And again, query takes in a row mapper, which in this case, you can just assign a Lambda expression to, takes the result set and a row number. And this is how we map columns to rows. And again, I kind of showed you this in the slides, but this is kind of code that I've written before using the JDBC template. What we can do now is use the JDBC client. So if we look at this, the first thing you'll notice is we declare a JDBC client. We will get an instance of this through, let's say, JDBC client, right? This will get auto-wired for us. This happens through the auto configuration, creates an instance of the JDBC client for us. And then you can just see this nice API that we get to use, right? Here's the SQL that I want to pass in. What I want to do is turn that into a post. And this is that post record that we just created. So it knows how to map the columns to that post that we just created. And then things like create. Here is a list of parameters that I want to pass in. Same thing with update, delete. If I wanted to find by a user, we could do that. If I wanted to save all posts. So just a nice API to be able to work with. So that is kind of one level of abstraction, right? Being able to insert some data into the database, read some data from the database, I could do that here. The other level of abstraction I told you about is, again, Spring Data. So if I wanted to, I can come in here and create an interface, and this can extend the list CRUD repository, and it just takes in the type and the ID type, and that will give you a bunch of functionality out of the box. So if you weren't aware, there used to be a CRUD repository. Now, in that CRUD repository, and there still is, the CRUD repository had methods like find all that returned an iterable. And we're kind of used to working with lists, right? I want to work with a list. So the list CRUD repository just exposes those methods with different return types. So you can see now, I can get a list back of things when I call find all, and then all of my CRUD functionality is still there. So the Spring Data approach says, oh, you don't need to write any of that SQL. We're going to we can generate a lot of those methods for you and still give you the ability to create more functionality if you need it. So I have that post repository. To do that, I have to do one more thing here. I'm using Spring Data JDBC. There are different flavors of Spring Data. Spring Data JPA is a very popular one. I happen to be a big fan of Spring Data JDBC. But you just have to do a couple of things. We have to annotate the ID with @ID. So that tells us which one that is. And then I'm using this thing, this version, and this is a way it kind of tracks, like, is this a new thing or is this something that we're updating? So we'll say integer version there, and let's just do that. All right. So now what I can do at runtime is I get access to that repository. So I have this command line runner here. So if you weren't aware, we can create a bean of type command line runner. And this is just a functional interface with a single method called run. And this allows us to do something after the application context has started. And what that means is that all of the beans in our system are now available. So I can say, hey, give me that post repository. We call that repository. And what I want to do is use that repository to save a new post to the database. Now, again, we didn't write this save method. This is part of the CRUD repository that the list CRUD repository extends. But this is nice. Now I can just say new post, and I give it an ID, a title. I'll say hello world. And then I'll say this is my first blog post. And then I have to pass a version, which in this case is just null. So what I get back, so that's fine. And then what I can do is use that repository to find all of the posts in my database. I'll get back a list of posts called posts, and then I can just go ahead and sys out or even use the logger if I wanted to. So what happens now, if we restart the application, the database should be updated with the new schema. When the application context is ready, we will save a new post to the database, and then I just want to call the database to get all of them, and then I'll list that out here. So let's see if we can do that. Cool. So there you see that post that's now in the database. We can even use our database tools here in IntelliJ, because again, we're connected to that local database that the service created for us. So let's say refresh, and then we see our database here. All right, so that's on the data side. What about on the client side? I have this client here. Let's call this a class for now. And what I want to do is I want to talk to that JSON placeholder service that we mentioned earlier. So I have this service. I want to talk to this. This is a public API, but you can imagine this is some service in your organization, right? So how would we do this before? Like before, I probably would have came in here and used something like the REST template. You can get an instance of the REST template. Again, when I start to look at this REST template, if I go in here and then look at the structure of this, you know, there's a ton of methods in here, like get for object, get for entity, head, post, put, delete, exchange, a lot of overloaded methods for exchange. And again, the API for this just kind of ballooned up. I didn't show you this, but in the docs for REST template, it says that it's feature complete. This does not mean that it's been deprecated. So I think people took that as, oh, they're getting rid of REST template. And that's not the case, at least for now. Like, it's not going anywhere. So if you're still in an application before like Spring 3.2 or whatever, feel free to use the REST template still. But if you can take advantage of something like the REST client, I suggest that you do. So how do we use the REST client? So we can say private final REST client. REST client, we can get a constructor parameter here. There is an interface on, this called builder, and then I can say builder.base URL. So I'm going to set the base URL to the service that I'm going to be talking to. In this case, it's the JSON placeholder service, and then I can call .build on this. Then we have a REST client instance that we can use. So we have, just checking in notes here. Next, yep, okay, cool. So now I have an instance of the REST client, and now I can go ahead and use it. So I want a method that will find all of the posts from that public API. So I'm going to say, hey, this is going to return a list of posts. We'll call it find all. and I can use the REST client that I just created. So REST client dot, and here's what I was talking about before. When I hit REST client dot, I'm given some methods: get, post, delete, put. This I understand. Like, I'm not inundated with overloaded methods on which one do I choose. This to me is very easy to read and easy to use. So I know what I'm doing here. So I know that in this case, I'm going to create a get. I need to pass it a URI. So the URI is from the base URL. What are we calling? In this case, it's /post. Then I have two methods. I can call retrieve or exchange. Retrieve is kind of the easier version. Exchange gives you a little bit more flexibility over using the request and response. In this case, I'm just going to retrieve. And what I want to do is, hey, when I get the body back, what do I want to do with it? I want to use the parameterized type reference. Yep, sure, no, don't need that. Yeah, so, and actually you don't even need to declare, oops. Don't even need to declare this, right? So this for me is pretty easy to read. So we're gonna make a call to JSON placeholder service. When I call find all, I wanna get all the posts, and that will return a list to me. So now that I have this post client, I can go back to my application. Instead of just creating one post, I want to create a bunch of posts. I want to create those 100 posts that come from that API. So I'm going to use that post client. We'll call this client. And I want to use that method to go get those 100 posts. So I'm going to say post client.find all, create a variable from this. We'll call this, what is it? Oh, yeah. So we'll get rid of that. So now I have all 100 posts from the external service, and now I can use the repository to save all. We'll save all those posts, and let's just do sysout on the repository.count. All right. So let's go ahead and rerun this. And now you can see that we have 100 posts. And if we go to the database and refresh that, we can see that we have all of the posts there. So these are all the posts that we got from that external service. Now that's great, but we can even take this one step further, one more level of abstraction. So we have this code that we've written, but we've written the underlying mechanism to talk to another service. So I can go ahead and get rid of this. I'm going to show you one more here. And we're going to create an interface, the same name, called post client. And now instead of writing the actual low-level implementation of that, I'm going to use HTTP interfaces. So I can use this get exchange to say, I want you to go ahead and create an implementation of this for me underneath the hood. All I care about is the contract. Like, I want to say, like, hey, this should return a list of posts. The name of this method should be find all, and that's all we're going to do there, right? So once we do that, there's a little bit of boilerplate you got to write to create a factory and create this instance of this REST client with the base URL. But now every method that we create in there, every contract that we create in there will get created for us. So we could even do one for being able to find a post by its ID. So if we wanted to do something like that, we can say return a post, find by ID. I could take an integer ID, and then we'll use something like the path variable, which we've seen before, right? So now we have these two methods in here, and you can imagine, we have a bunch of methods in here, and these all get turned into implementations at runtime by Spring for us. So now what this means is this code shouldn't change, right? I still have a post client. I still have a method called find all. If I run this again, this should go ahead and start up, find all of them. Looks like it did. Now I can use another method here to say client.findByID. So let's find the first post. turn that into a variable, and then I can go ahead and sys that out. And if I go ahead and rerun this application here, the very last line should have just the single post, which it does. So yeah, just some different levels of abstractions from the JDBC client and the REST client. So I'm coming up on 10 minutes here. It looks like I have 10 more minutes. So I'm going to pick out one thing to talk about really quick from the standpoint of runtime efficiency. And I want to kind of cover virtual threads real quick. So Java threads. A thread is the smallest unit of processing that can be scheduled. It runs concurrently with and largely independent of other such units. It is an instance of java.lang.thread. Consequently, the number of available platform threads is limited to the number of OS threads. And really, a platform thread is a wrapper around an OS threads. The thing to understand here is that platform threads are very expensive. They take a lot of memory to create and destroy. A little bit more on this in a second. And platform threads are stored on the JVM stack. So a thread is not cheap. Thread startup time, somewhere around 1 millisecond. Thread memory consumption, around 2 megabytes of the stack. And then there's some context switching depending on the OS threads. There's a really good video on this by a developer advocate at Oracle, who you probably all know now, Jose, who does a really great talk on virtual threads, a little bit more in depth than I'm going to do today. And so I took kind of these numbers from him. But what he got to was, if you go through the math here and try to figure it out, like having 1 million platform threads is not possible. And so this is where we start to see some of the bottlenecks in our applications in higher throughput concurrent applications. So what are virtual threads? Virtual threads are a lightweight threads that reduce the effort of writing, maintaining, and debugging high throughput concurrent applications. Two keywords kind of stick out there, right? Lightweight and being able to produce high throughput concurrent applications. So like a platform thread, a virtual thread is also an instance of java.lang.thread. It is not tied to an operating system thread, which is important. And a virtual thread still runs on an OS thread. It uses the heap for the stack, which has some implementations for garbage collections. They have their own scheduler, so do not create schedulers for these. They have their own scheduler, but they also do not pull virtual threads. It has like their own fork join pool. You don't want to pool these virtual threads. They're very light. You don't need to pool them. They're easy to create and destroy. I'm going to skip some of this. I just want to talk about kind of Project Loom. And so with Project Loom, when you hear about Loom kind of synonymous with virtual threads, Project Loom is made up of a few JEPs, JDK enhancement proposals. Virtual threads went final in JDK 21. We had the second previews for structured concurrency and scope values in 22. I believe these are going into another preview in 23, but these all are around the idea of virtual threads. So you want to take a look at structured concurrency and scope values too, because they have some, they're related to virtual threads. I wanted to get into this, but I'm not going to. I just want to kind of show you a quick demo, and then we'll kind of wrap this up. So I have this application here, and I have a home controller. So what I want to point out here is, and actually, let me see if I wanted to point one more thing out. Where is that? Yes. So let me just kind of point this out, and then we'll go into the code. So we'll talk about enabling virtual threads. The important thing to understand here is that when we enable virtual threads, this will cause Spring Boot's auto configuration to request virtual threads in any library that supports it. So Spring MVC is one of those, right? If you create a controller and you handle a request in a controller, it's now enabled to use virtual threads. this doesn't mean that every single piece of your code is now ready for virtual threads, right? It's wherever it supports it. So the web server, the embedded web server, task executors, client libraries like Rabbit and Kafka and Pulsar. The way that it does this is through auto configuration. You'll see this is a Kafka annotation-driven configuration. There's a conditional on threading annotation. It says, hey, if the threading is platform threads or normal threads, right? Here's how you're going to configure yourself. If threading.virtual is enabled and virtual threads have been enabled, let's go ahead and set that up so we can take advantage of virtual threads. So I think that's important to understand, and I'll show you a quick demo of that. So here in my home method, which is mapped to the default URL. So when we fire this up, localhost 8080, we're just logging out a string here that says thread, give me the current thread, right? So if I went over to a terminal and I made a simple request to localhost 8080, and then looked at the console here, you can see the thread is the main thread. So we're using platform threads in this instance. But if we go into our application.properties and we want to enable this, all we do is turn on a single property. Again, one of the things that really excites me about this is probably don't have to rewrite a lot of code to make this happen. We're not asking you to rewrite entire applications. We're just flipping a switch there. So I'm going to restart the application. I'm going to go back to my terminal. I'm going to make that same request to localhost 8080. And now you can see that we are using a virtual thread. So we're taking advantage of this, and you can see that it's under this fork join pool. So this is going to allow us to create, in the past, we've kind of went about different ways to scale applications, right? Like we're getting a lot of throughput. We may need to scale it using more memory and CPU, more hardware, or we may move to something like reactive programming to kind of solve this problem. And now this just offers another mechanism for scaling our applications, especially on like the Spring MVC side, wherever we're doing some kind of blocking mechanism, talking to a database, talking to another service, which we did in our example today. So I wanted to point that out because if you were to go into something like this and copy that, so let's go ahead and copy this line and go into our just here. I just want to paste that, and if I go ahead and run that, you'll see that that one is still using a main thread because we haven't told it to use virtual threads here, right? We're using it wherever it's been enabled in Spring MVC controllers, in Kafka, if we use that, wherever that is, virtual threads are enabled, that's where we're going to use it. But again, we're on JDK 21, so we could take advantage of this if we want. We could say thread.of virtual. So we could say of virtual, we can go ahead and start one. So start. And then we can just say in here, let's go ahead and log that. And then rerun that, and now that should be a virtual thread. So again, I just kind of wanted to point that out because we are enabling virtual threads wherever we can, wherever it's supported. But in your code, that doesn't mean that it's just automatically everything is a virtual thread. You still need to understand like how to take advantage of virtual threads in your own application. So unfortunately, I am running up on time, but I just wanted to kind of quickly point this out. Spring Framework 6.1 was released in November of 2023. This is the foundation for Spring Boot 3.2 and 3.3. Again, 3.3 was just released. And yeah, and these are production ready on JDK 17 and 21. So if you want to learn, if you want to contact me, dan.vega@broadcom.com, @TheRealDanVega on the Bird app. You can always find out more about me on danvega.dev.
Yeah. Big thanks, Dan, for sharing your knowledge. Your talk was very clear and useful and helpful. I guess we are limited in time, but I have one question from my side. So
yes.
My question is, what you are expecting in the future of Spring? What are you looking forward most?
Yeah, I think you know, from the idea of runtime efficiency, right? We talked about virtual threads today. There's ahead of time compilation. There's Project CRaC. There's something called CDS that dropped in 3.3, and it's just again, we're all taking different workloads to production, different types of applications, and Java and Spring are giving us the tools to run these applications in production. So CDS allows for a faster startup. With something like Project Layton coming in future versions of the JDK, this is going to be a recurring theme. And I think, you know, in the past, people might have reached for other languages. Go was a huge one to reach for because of concurrency, right? And I don't think that's a case anymore. I think JDK, I think Spring, we have options for all the different types of workloads that we're trying to take to production now. Oh, I can't hear you.
What about now? Now it's good. So
yes,
thank you so much for your answer. Yeah, I like it. We also have a couple of questions in our live chat in YouTube.
Mm-hmm.
And it would be really nice if you can handle it directly in this chat and provide answer to people.
Okay, cool. Yeah, no problem.
Thank you for joining us. Looking forward to next year to see you again.
Awesome. Yeah, thank you so much. I appreciate you guys having me. Have a good one.